Hello everyone, this is Mr. Appel. So in the example I just showed you above in the playlist, we saw that that this expression, the thing we started with, simplified to this expression. And so that tells us that those two expressions should be equivalent, they should be equal. Just like when we had 10/16, that was equal to 5/8, right? Those are both the same value. You put them in the calculator, you get the same thing. They are equal. However, in this case, when we're dealing with these algebraic fractions, we have a problem, which is we cannot divide by 0. You can't have 0 in the denominator of a fraction. It's undefined. And so whenever we're working with algebraic fractions, with rational expressions as we call them, we have to be aware of accidentally dividing by 0. So let me show you an example of what I mean. We're saying that these two expressions are equal to each other. So if I pick a value for x, I should get the same thing. So let's just pretend x equals, I don't know, let's say 4. So on the expression on the left, I'd have 4 squared, which is 16, minus 3 times 4, which is 12. On the bottom, I'd have 4 squared, which is 16, minus 9. And I would get 4 on the top and 3 on the bottom. And if I plug that 4 in over on the right side, I'd get 4 on the top, and 4 plus 3 is 7 on the bottom. And, oh, I knew something was wrong there. Going back over here, 16 minus 9 is actually 7. Sorry. So you notice that I get the same answer either way, which makes sense because I'm saying that these two things are equal. Okay, but now watch this. What if I try for when x equals 3? On the equation on the left, I get 3 squared, which is 9, minus 3 times 3, which is 9. And on the bottom, I get 3 squared, which is 9, minus 9. I get 0 over 0, which is undefined. That makes no sense. When I plug 3 into the expression on the right, I get 3 on the top. 3 plus 3 is 6 on the bottom. I get 1/2. They're not equal. The reason they're not equal is because they're only equal for x values that are defined, for x values that don't cause division by 0. So anytime I make a claim like this, it's true, I have to say it's true for all x values except the ones that make the denominator 0. So if I look at my original problem, I'm going to get rid of all this for now. If I look at my original problem, I'm asking myself, what would make the denominator be 0? Well, we can figure out what would make that denominator be equal to 0 by solving that quadratic. I can solve it by factoring. X plus 3 times x minus 3 equals 0. So negative 3 or positive 3. So either of those x values would cause a problem because they would cause the denominator to be 0. So we call these our excluded values. Those are the values of x for which this is not true. And so I'll always ask you what values of x need to be excluded, or which values of x will make it undefined. And so somewhere here it's important that we say, this is our answer, right? This is what we got when we simplified, but x cannot equal negative 3 or 3. And so we need to include that as part of our answer. That's all for now. Thanks.